All right, class. So in the last class, we had completed the revision of EMI, no? Priya, some chapters have been missed by you. Priya, one more thing I want to ask you. Apart from this batch, I think you're available for this batch. Are you available on Monday and Wednesday? This is just for Priya Darshini. Are you available on Monday, Wednesday? Time will be the time that you had for the other batch. It's 9, so that will be, I think, 7:30. 7.
Yes, ma'am.
Yes, your timings both the days.
Yeah.
Okay, so I think it's better if you join that batch. I'll just a second. Yes. Yeah, so I was talking to Priya. No, yes, Priya Darshini. So Monday and Wednesday, this is the timing. You will get the link. So on Monday, we have completed revision till dual nature. So we'll be doing atoms, nuclei, and semiconductor, and after that, once again, the complete revision will start. So I think you'll be able to tally up there also. Revision of join with the revision of atoms, nuclei, and semiconductors. If you want, you can attend today's class as well. AC we are going to do, but I think I'll suggest you if you could join that batch, because again we'll be starting with, and lots of new questions are there. So I think that batch will help you. So if you're available on Mondays and Wednesdays, I'll shift you in that batch. Okay, Priya?
Yeah, ma'am. Also on Monday and Wednesday.
Okay. Okay. So, and if you want, you can attend today's class also. It will be a revision class only, because here also I'm discussing the previous year's questions only right now. First round of revision is only going to. Yes, class. So let us practice some questions on alternating current. EMI we completed in the last class. So yes, class, the topics that are important, I think someone was asking also, root mean square, which we say na effective value of AC, that is very important. Average value and RMS value. The derivation of both these values can be asked. More than the numerical, the derivation part is very important, because lots of questions have been asked where direct the question has been mentioned, like what is meant by RMS value or effective value of an alternating current, derive its relation between it and the peak value of it. So like this question will be asked, where you have to mention that the effective or RMS value of an AC is 1 by root 2 times its peak value. So that part is important, right? Or for that relation, it can also be asked for average value over half cycle, average value over full cycle, and full cycle, you know the answer, anticipated answer is there, and it will be 0. So that part can be asked, and from that part you will have numericals as well. Maximum types of numerical from this we have discussed. Let us practice one type of question, then I'll discuss this part, this derivation that we have. These derivations are very important. Let us practice one question from this part. Currently, whatever questions we are practicing, these are mainly from your previous years that have come, that have repeated itself. Note down the question. Very easy question is there. Resistance is given, voltage, frequency is mentioned, peak potential difference, average potential difference, RMS current. At least answer the first, second parts. I'll discuss it after 2 to 3 minutes. So only 2 students have answered. Let's discuss this. So Hamza and Priya, yes, first part is correct for both of you. See, resistance is given RMS value is given. Resistance is given 100 ohm. ERMS is given as 220 volt. And ultimately you have frequency as 50 hertz. It is asking what is peak potential difference. So peak value of potential difference, peak value of EMF, that is root 2 times the RMS value. So this becomes 220 multiplied by root 2, right? So that will be around 311 volt as rightly answered by Hamza and Priyadarshini. Then second part says average value. So average value, this relation I was mentioning you, the derivation of this relation comes. This is 2 by pi E naught. So 2 by pi, you can write it as 0.637 as well. Try to remember this value because this will be used. Instead of you'll be dividing 2 by pi, it's better if you remember 0.637 multiplied by E naught. So that is 300. So answer should be 198 volt around this. And the last part is RMS current. So again, RMS current is easy. ERMS divided by the resistance. Simple Ohm's law, the way we use, no, V is equal to IR. So I will be V by R. So ERMS by R. ERMS was 220. And this is 100. So current will be 2.2 amperes. Note down the solution. Let's see some more questions. Okay, so now, and after this, then your individual circuits come. Circuit having only resistor, circuit having only inductor, circuit having only capacitor. So when an AC circuit is there that is having only resistor, so that case resistor is present, both are in the same phase. Phase difference is same between the potential and current. Same phase means there is no difference. Phase difference does not exist. Then for an AC circuit containing only inductor, one quantity that gets introduced, that is XL. This is the resistant inductive reactance, which is equal to omega L, which is equal to 2 pi nu L. Any of these can be used. Then current. Current will be E naught by XL. Wherever you are using R, you will be using XL, like IRMS. So ERMS by XL, like this. This was for purely resistive. This changes for purely inductive. For purely capacitive circuit, capacitive reactance will be there. That will be XC. This is 1 by omega C or 1 by 2 pi nu C. This is XC. Fine. So current amplitude will be, again, wherever you were using resistance work, that will be provided by XC. Right. So let us practice some questions on these individual circuits. Then we'll see combination of the circuits. A 1.5 microfarad capacitor is connected to a 220 volts 50 hertz source. Find the capacitive reactance and the current, both RMS and peak in the circuit. If the frequency is doubled, what happens to capacitive reactance and current? So see what all data we have. Capacitance is given 1.5 microfarad, 1.5 into 10 to the power minus 6 farad. ERMS is also given 220 volts and same data. Frequency is 50 hertz. So capacitive reactance, Xc, this will be 1 by 2 pi nu C. So 1 by 2 pi will be 3.14. Frequency is 50. Capacitance is 1.5 into 10 to the power minus 6. So once you'll solve this, you will get it as 212 ohm. This will be the capacitive reactance. So resistance you have. Now IRMS will be ERMS divided by the value of Xc. ERMS is 220 divided by 212. So that makes it 1.04 ampere. So like this, we'll find RMS value. Same way, if you want to find out peak current, but one thing you can do is convert ERMS into peak EMF and divide it by XE. Or direct, if you have IRMS, I naught will be root 2 times IRMS. So that will be root 2 times 1.04. So this will be around same thing, same 1.41 into 1.04 it will be. So 1.47 ampere. And see if the frequency is doubled, what happens to the current and the capacitive reactance. See if the current in the circuit oscillates, it will oscillate between these two values. This value, this is the RMS value. So current will be oscillating between, see here, current will oscillate between, this is the peak value, so maximum value along the graph. If I draw it like this, let's say this is the mean position, this is the extreme, this is the extreme. So current will oscillate towards extreme position and between the another extreme position. So that will become plus 1.47 to minus 1.47 amperes. And about the frequency, see Xc is inversely proportional to frequency 2 pi nu C. So Xc is inversely proportional to frequency. So what is the question saying? Yes, if frequency doubles, then current is also doubled, capacitive reactance is halved. So Xc is halved, Xc becomes half. And what happens to current? See, current is inversely proportional to Xc. So current will become double. Note down the solution. Any doubts you have asked me? Let's practice some more questions. Now see, you have combinations also. You have LR circuit, which involves inductance along with the resistance connection. Fine. Now, in LR circuit, you have to remember that IRMS, Z you will use, impedance. So in LR circuit, you will be having XL and R only. Like ERMS is equal to IRMS multiplied by Z. So here Z will be just under root R square plus XL square. XC won't have any mention over here. Even when you'll calculate phase angle, that is tan phi, you'll write it as XL divided by R. Current IRMS will be ERMS by Z. Z will be under root R square plus XL whole square. Now from this part, from your examination point, directly numericals are more important than the derivations. More than the derivations, you have the numerical part that is more important. Then LR circuits you have, RC circuits you have. Let us do one thing. Let's practice direct questions. From there only we'll revise. First, let us discuss LR, because then lastly we'll do LCR circuits. See, yes, answers, class. I think lots of time have been given to you for this question. When 200 volt DC are applied across a coil, a current of 2 amperes flows through it. When 200 volt AC of 50 CPS, this is basically current per second, that is your frequency, are applied to the same coil, only 1 ampere flows. So you have to find out the value of resistance, impedance, and inductance of the coil. So see, for DC, voltage is given as 200 volt. For the first part, DC, voltage is given as 200 volt and current is given as 2 amperes. So what will be resistance? Resistance will be V divided by I. That is 200 by 2, which is 100 ohm. Fine. Now, so resistance is that the resistance will be directly calculated. That is the ratio of voltage and current. Secondly, you have to find out impedance and inductance. See, impedance will be how we'll calculate the impedance. ERMS is given 200 volt. IRMS is given to you 2 amperes. So Z will be simply ratio of ERMS and IRMS. That will be same answer. I think we'll get. No, IRMS is 1 amperes. No, this is only 1 amperes. So this will become 2 amperes was for DC. So this becomes 1 ampere. So answer will be 200 only. 200 volt by 1, that is 200 ohms. So resistance done, impedance done. Now inductance. Omega, from impedance, resistance, we can calculate inductance. See, Z is equal to under root XL square plus R square. So XL square will be Z square minus R square. So XL we can write it as omega square L square. This is Z square minus R square. So omega square L square will be Z square. That is square of 200 minus R. R was 100 minus 100 square. And omega, so omega L will be 100 root 3. This will be omega L. This will be 100 root 3. Now L we have to find out. L will be 100 root 3 divided by omega. And omega is directly not given, but we have linear frequency. So 100 root 3 by 2 pi nu. So put in the value 100 root 3 by 2 into 3.14. Frequency was 50. So frequency will be 50. So answer will come around 0.55 Henry. So this is the answer. All the three things we have calculated. This was Z, impedance was 200 ohms, and resistance was 100. Note down the solution. At least in the fourth question, tell what is the value of impedance that you're obtaining. Yes, class answers. What is the value of impedance that you're obtaining? Akifa, Fatima, Hamza, Huzefa, Priya, Sara. See, what is the value of current in the AC circuit containing resistance as 10 ohm, capacitance as 50 microcapacitance, make 50 microfarad. This will be 50 microfarad in series around 200 volt, 50 hertz AC source. So we have to find out current. So first we'll calculate the impedance, because ERMS you have, IRMS you have to find out. So Z you want to calculate. So this will be R square plus XC whole square. XC is also not given directly. So our resistance is given, no? This will be 1 by omega C. whole square. Or you can write this as r square plus 1 by 2 pi nu c whole square. Now put in the values. Resistance is given how much? 10. So 10 square plus 1 by 2 into, okay, this is square it. You have to square it. Let me write it like this, only 3.14 into frequency is given 50. 50. See, frequency is 50 and capacitance. Capacitance is also 50 microfarad. So 50 into 10 to the power minus 6 and whole square of this. Did anybody solve this part? This is a question from your exam only. These types of questions will be there. Value of Z will be around 64.4 ohms. Now you have to find out current. Current will be ERMS divided by Z. This is 200 divided by 64.4, which is equal to 3.1 amperes. Fine, this is the final answer, current. This is Z. Any doubts you have in here? All these questions are which we are practicing are the questions that have repeated multiple times in your exam. Note it down. Let's see some more questions. A resistor of 50 ohms and an inductor of 20 by pi and a capacitor of 5 by pi microfarad are connected in series to a voltage source 230 volt and 50 hertz frequency. You have to find out impedance. Yes, what was your answer? What all answers have you got? Yes, Sarah, Zephyr. Okay, Hamza has answered. Yes, Hamza, your answer is correct. Good, Hamza. Akifa, Fatima, your answers? Hiba, Hanifa, you people have not answered a single question. All these questions are from your previous year. This question last came in 2016. Once in 2006 and once in 2016. See here what all things are given. This is an easy direct question. 50 ohms is the resistor that is given. L inductance is 20 by pi Henry. Capacitance is 5 by pi micro. So 10 to the power minus 6 farad. All these are connected in series to a voltage source. Voltage source means ERMS is given to you. This is ERMS and this is frequency. You have to find out impedance. So you will be needing XL, XC. How will we calculate XL? Yes, what is the formula of XL? Fatima. Yes, Hiba, correct answer. Fatima, what about you? How do we write XL? Is Fatima present or not?
2 pi nu L.
2 pi nu L. Yes, correct. See, omega L we write, and omega we can write it as 2 pi nu L as rightly answered by Fatima. So this is 2 into pi and frequency is 50 and L is 20 by pi. So see, pi will get cancelled. So you will be left with 2000, right? This is 2000 ohms. Then we have XE. Yes, Akifa, what is the formula of XE? Capacitive reactance. Josefa, formula of XE. Okay, Akifa has answered 1 by 2 pi nu c. Correct. 1 by 2 pi nu c. We write it as 1 by omega c. So this will be 1 by 2 pi nu c. So 1 by 2 into pi into frequency into c. That is capacitance is 5 into 10 to the power minus 6 with pi will go up. So this will also be around 2000. Not around, exactly 2000. So is there any condition that you are able to observe till here? Though nothing is mentioned in the question, but by looking at the data that we have calculated till here, is there anything that you can name this condition as? Anyone? Yes, good, Akif. A resonance condition. See, XL is equal to XC here. If you notice, XL is equal to XC. This is resonance condition. And what is impedance in case of resonance? Impedance becomes equals to the resistance. So answer will be 50 ohm directly. Otherwise, if you calculate it properly also, you'll get the same answer. Resistance will only be the answer. Right? So if you identify, that will make your work easier. Copy it down. At least answer the first two parts, XC, XL, calculate these. Then using those and the resistor value 100 ohm, calculate impedance. Once you'll get impedance, then the rest of the questions will be quickly solved. Right. One student has answered Hanifa. Good, Hanifa. Correct answer. Others also see, let us at least discuss this frequency part, then you can solve for XC and XL once we have frequency. See, for frequency, this is the resonance condition. Current drawn in the circuit will be maximum when current is maximum. This condition is also known as resonance condition, right? Akifa, do you agree? In the previous question, you have mentioned resonance condition when XL was equal to XC. Here also it will be the resonance condition, right? So current drawn is maximum means resonance. And in resonance, how do we calculate the frequency? We calculate the frequency using the formula 1 by 2 pi under root 1 by L. See, this is the formula. So 1 by 2.314 LC, it is 8 given, no, 8 henries. And capacitance is given as 2 microfarad, right? So 2 into 10 to the power minus 6. So 16, that will make it 4. 4 into 10 to the power minus 3. So 1000 by 8 pi basically. So once you'll solve this, you'll get your answer around 40 hertz. Exact answer would be something 39.8 hertz like this. Now you have frequency. Now at least tell me what are the values of XL, XC you're obtaining. Yes, good Hamza. C class, the resonance condition. Once it is declared that this is a question from resonance, so many things get cleared. XL and XC will have the same value now. No, XL becomes equal to XC. See, XL, calculate any one of it. Let's calculate XL. 2 pi nu L. See, this will be 2 into 3.14 into frequency is 40 and inductance is 8. So this will be the same thing will come. 1000 by 8 pi is only coming. So around 40. Uh, no, this will be 1000 by 8 pi multiplied by 2 pi. No. So that will be 2000. Right, right. So yes, Hamza, correct answer. It will be 2000 only. 2000 ohm. Now, since it is resonance, XL will be equal to XC. So XC will also be 2000 ohm. Fine. And class, for the second part, that is impedance, please tell me impedance quickly, even without calculation. Z equal to in resonance condition. Yes, class. Good Fatima, it is equal to R. So this will be equal to R, which was how much? This is the answer. Tell me the answer last two parts, class. See, once you identify that it is resonance, frequency becomes easier. This differences answers. Note down these three and answer. Class C, you don't even need to calculate the other parts as well. For phase difference, see what will you get the answer for phase difference. Phase differences between voltages across inductor and resistor. This is fixed. Phase difference between resistor and inductor. This is fixed. So this is difference between inductor and capacitor will be 180 degree, right? Between the voltages between capacitor. Learn this as a theory part as well. This will be 90 degree and this will be 180 degree. That's why I was saying in this question, you don't have to calculate much. Once you identify that this is the question from resonance, after resonance, many things become clear. All right. Then you have one more topic. Let's discuss that. Then I'll finish the class. So numericals part, I think most of the questions that have come in your previous year, I have discussed it with you. Now, see here. Q factor, we did it. If you remember, we did Q factor. That is known as quality factor. So Q factor is actually equal to frequency at resonance by final frequency minus initial frequency, the difference between the two frequencies. Or this can also be written as omega r L by R. Class, the derivation, its derivation is important. Prepare its derivation in the test that I have taken. I have asked IC, I think I've taken in this batch as well. So Q factor is omega divided by omega 2 minus omega 1. Or one more formula it has, that is 1 by R under root L by C. Under root L divided by C. So these, any of it can be asked. You should remember that omega 1 and omega 2, these are the frequencies. Omega 1 and omega 2 are the frequencies at which current falls to 1 by root 2 times its resonant value. So this 1 by root 2 is important. One by root 2, this formula and the derivation. Questions class from this topic will be very easy to discuss, very easy. The questions that will come from Q factor. So prepare Q factor well. One more thing, remember, cos phi will be equal to R by Z as well. That question can also be asked to you. All right, these questions can be asked. Then tan phi, yes, one more thing. Tan phi become equal that you don't need to put it. If it is, and they have resonance as the most important. All right, resonance is the prime important topic. If you are short of time, so tan phi will be mentioned XL minus XC divided by R. So from here again, cos phi will still be R divided by Z. This will remain fixed. And then again, you know Z will be the same thing that we have discussed, R square plus XL minus XC whole square. XL minus XC whole square or XC minus XL whole square. XL minus. This depends upon whose value is more. If the value of inductive capacitance is more than, capacitive reactance is more, then you will put this one. If XL is greater than XC, then we'll use this. All right, class. So I'll stop here. I think the entire lesson we have done it. Maximum question class. When you're revising, pay attention to solve all these questions and everything that you have. then practice these. Now we'll be starting with second book. In one day, I'll tell you you will be revising EM waves. I'll be taking your viva of EM waves. I'll be asking you questions from EM waves. So that is also there. EM waves also we have to do, but we'll be doing the revision of optics. In first book, any doubts if you have, you can ask me, you can text me the question, you can send me the pic of the question also. So I'll stop here today. And now we have the class on Tuesday. All right, we'll continue on Tuesday. Thank you so much, class. Thank you.
Thank you, teacher.